Hello everyone and welcome back to our channel. Today we are going to discuss a very important topic which is linked list. So the contents of today's video are going to be linked list versus array, singly linked list, doubly linked list, circular linked list and doubly circular linked list. Now what is a linked list? A linked list is a linear data structure in which the elements are not stored in contiguous memory locations. So a linked list can be defined as a collection of objects called nodes which are randomly stored in the memory. A node contains two fields, that is the data stored at that particular address and the pointer which contains the address of the next node in the memory. So here in this picture you can see a linked list. Now this blue block is known as node, which contains data and a pointer with an address to the next node. So the last node points to null. Now linked list versus array, and why linked list is a little better than the array. So linked list elements can be stored anywhere in the memory, while array elements have to be stored in contiguous memory locations. Now sometimes array works better since they are stored in contiguous memory locations. We can guess the location of the next element with the address of the previous element. Linked list works with dynamic memory, that is, the memory size can be changed during runtime according to our requirements, while array works in static memory, so the memory size cannot be changed at any time if we set it at the beginning. Now linked list takes less time while performing any operations like insertion, deletion and etc., while array takes more time while performing such operations. Now let's see the types of linked list. So our first type of linked list is singly linked list. So singly linked list can be defined as the collection of ordered set of elements. Now singly linked list can be traversed only in one direction, that is from head to null. It cannot be traversed in the reverse direction. Each node contains only next pointer, that is the pointer to the next element or the address to the next element. Therefore we cannot traverse the list in the reverse direction. So this is an example of singly linked list. Now let's see singly linked list in more detail. Now here we can see an example of singly linked list. This here is the head. And this is the last node which is pointing to null. So here we can see that each node contains the address of only the next node and nothing else. So this can be traversed only in one direction. It cannot be traversed in reverse direction. So now let's see the code for singly linked list. Now let's see the code for singly linked list. So first of all, we'll need to include the libraries required for this code. Now let's start by introducing a structure in which we are going to introduce two elements, which is data and the pointer. Now we'll start with the main function. So first of all, we'll need to initialize four elements or four pointers, which will be head, now you can name them anything. It is just I am using the variables so that it is easy to understand. and fourth. So now the next thing which we have to do is allocate memory for these nodes in heap. In heap. So how do we do that? So for this we are going to use the malloc function. That is the malloc which was introduced so that we can allot or allocate the memory in heap using dynamic allocation. So for we have to do that for each of these variables. So this is the standard method, or we can say the uh, standard code which will be used for allocating the memory. We can also use uh, object-oriented programming for this. Now we'll just copy this for each of the variable. Since we can see that the code is almost the same, only the name for the variable is changing. So now we have allocated memory for all the four variables. Now what we have to do is we have to link these nodes and give some data that that is to be stored in these nodes. So how do we do that? For that we use the arrow operator, which is this. So here we can see that VS Code has already given us options for storing the data or the next pointer. So first of all, we'll store some data. Let's say any number. And the next thing which we have to store is the pointer to the next node. We'll just store the name. Similarly, we have to do it for each of the variables. And here we'll give the third. For third it is fourth. And it goes on, and the fourth one is the last. So for fourth one we'll have to give the next as null. Null. So here linked list code has completed. Now how to see if this is working? For that we have to code a function which traverses throughout the linked list and prints the elements of the data stored in the nodes. So let's initialize a function which takes a pointer, the node pointer, and traverses throughout the linked list. So for that we'll use while loop. So unless and until the pointer does not become null, this function should run. /n, then the data which is stored in that node, and after every iteration the pointer points to next one. That is, the current pointer becomes the next pointer. Yeah, so that's it for the function. Now we'll have to call this function here. And we'll pass the head. Yeah. So let's run this and see if our linked list is working. Okay, we are facing some error here. Oh, sorry. There is a tiny mistake here. Okay, so now I think we are good to go. Yeah, so we can see that the function has worked properly and it has traversed throughout the linked list and printed all the elements present in the linked list. Now let's see the next type of linked list. The next type of linked list is doubly linked list. So a doubly linked list is a linked list which contains an extra pointer, mostly called a previous pointer. Now, basically this means that each node will contain two pointers, one which points to the next node and one which points to the previous node. So the previous part of the first node and the next part of the last node will always contain null, indicating end in each direction. And a doubly linked list can be traversed in both directions, that is the forward direction and the reverse direction. So this is an example of doubly linked list. We can see that the last pointer is pointing to null and the first pointer is also pointing to null. So let's see doubly linked list in a bit detail. So this here we can see a singly linked list or a normal linked list. So what is the difference between singly and doubly linked list? So each node will contain one more type of pointer, which is the previous pointer, which points to the previous node. So basically this is how a doubly linked list will look. Also the first pointer will point to null. So the both endpointers will point to null. So this is how a doubly linked list looks. So let's see the code for doubly linked list. So for coding part, we have done a few changes in the previous code of singly linked list. So the first change which we have done is we have added one more pointer here which points to the previous node. And another change which we have made is in the function of traversal. So what we have done is we have introduced one more pointer here which is last. So what it does is first in the first while loop the linked list traverses from the first node to the last node along with the last pointer. Now after this traversal, the pointer which we have introduced, that is last, is now at the last node. Now after that we again introduce one more while loop, and this while loop traverses in the reverse direction, and for that we use this pointer, the last pointer. So now currently the last pointer is on the last node and it starts traversing in the reverse direction unless and until it is not equal to null, since our first node is also pointing to null. So in this way, this while loop works. And in this function, we traverse in the forward as well as the reverse direction. So the next change which we have done here is that we have added each one line to each of these variables, which is the previous pointer. So here we can see that the first node is pointing to null. The previous pointer of first node is pointing to null. Then the previous pointer of second node is pointing to the first node, that is the head. And similarly for third it is pointing to second, and for fourth it is pointing to third. And after that we have again called the linked list traversal function. Now let's see if the code works. Okay, there is an error here. Okay, I don't think this is any kind of error. Yeah, so I guess there was some mistake in the compilation process. So our code has uh, compiled successfully, and here we can see that first traversal in the forward direction, and it has printed all the elements, which is 10, 20, 30, and 40. And again it has traversed in the reverse direction, in which we have printed the whole linked list in the reverse direction, which is 40, 30, 20, and 10. So in this way a double linked list can be executed. Now let's see the next type of linked list. Next type of linked list is circular linked list. So in circular linked list, the last node of the list contains a pointer to the first node of the list. So the pointer in the last node will point to the first node again. So we traverse a circular linked list until we reach the same node where we started. So since it is a circular linked list, there is neither a beginning nor an ending to the circular linked list. So therefore there is no null value present in any of the next part of any of the nodes. So this is an example of a circular linked list. As we can see that the pointer of the last node is pointing to the first node again. So let's study circular linked list in a bit more detail. So this is a singly linked list. Now what changes are made to achieve a circular linked list are that first of all we have to point the last node to the first node. So that means the pointer in the last node will point to the first node. So in this way it will form a circle. So there is no ending nor a beginning to this linked list, and there won't be any null value or any pointer pointing to the null value in this linked list. So it is always traversing in a circular direction. So let's see the code for circular linked list. So this is the code for circular linked list. So basically this is the code for singly linked list with a few modifications. So the first modification which we have done is before we used here null for the next pointer of fourth node, but now we are pointing it to the head, that is the first node. Similarly, we have made few changes in the traversal function. So first of all, we have made a change here. Here we used to pass some pointer or just a pointer, but we are specifically passing head here. Now secondly, we are initializing one more pointer here, which is to which we have assigned the head. And now we are running a while loop with this condition. So the thing about this while loop is that it will go until the second last element and stop there. So it won't go to the fourth element. So that means the last element. So what happens is it will print only till the second last element, but not the last element. So to do that, what we can do is we can either use a do while loop to print the last element along with all the elements, or we can do something as we have done here. We can separately print the last element. So let's try running this loop. Yeah, so we can see that it has successfully compiled and it has printed all the four elements. Now, let's see what happens if we comment this one out again. Yeah, so we can see that it is printing only the three elements. That is the first, second, and third, and it is not printing the last element. So what happens is it traverses only till the second last element, and it won't print the last element. So that's why we use either a do while loop or we can separately print the last element. So this is the implementation of circular linked list. Now the next type of linked list is doubly circular linked list. So doubly circular linked list is a more complex type of data structure in which a node contains pointers to its previous node as well as the next node. So basically doubly circular linked list is a combination of doubly linked list and circular linked list. So it will have the functionalities of both. That is, it will contain the each node will contain the address of the next node and the previous node, along with the last node will contain the address of the first node as its next address. So there won't be any null in any of the node. So there is no null pointer or a pointer pointing to the null. And the last node of the list contains the address to the first node of the list. So this is basically a combination of both type of linked list which we have studied before. So in this picture you can clearly see that each node contains the address to the next node as well as the previous node, and the last node contains the address to the first node, that is the head. Now let's directly jump onto the code for doubly circular linked list. So now for the coding part of doubly circular linked list, we have done nothing different. We have basically just combined the coding parts of circular linked list and doubly linked list. As you can see, we have introduced the one more pointer, which is the previous pointer, as we did in the doubly linked list. And uh, here what change we have made is that the previously in doubly linked list, the previous pointer of head used to be a null, but now it is fourth since we have also combined the circular linked list. And this property of circular linked list, where the next pointer of last node, that is the fourth node, is the first node again. So here we have done that. And another changes that we have made in the traversal function is that we have done nothing different. We have just basically combined circular and doubly linked list. As we can see that this while loop which we used to do in the double linked list for forward and reverse traversal, we have done that as it is. And then what we have done is, as we saw in the circular linked list, that the last element is not printed, so we have separately printed it for both the times. So yeah, that's it for the code. Let's see if it runs. Okay, there is some error in the code. Yeah. So as you can see that it has successfully traversed in the forward and reverse direction, and it has printed all the four elements in both the directions. Like for first time it has printed in the forward direction, and for second time it has printed in reverse direction. So yeah, actually, doubly circular linked list seems to be a complex data structure, but actually it is the easiest one if you have understood the circular and doubly linked list. So that's it for the code of doubly circular linked list. Thank you so much for watching our video, and stay tuned for more such informative videos.